Hello there, young students of chemistry. This is a quick recording regarding substances. So, substances in chemistry is a very wide category of items. It would include just anything that exists at all, we can call a substance. But it is important for us to identify substances and how they break down into different categories. So we will start by talking about substances that are pure. There are two types of pure substances, and those are elements and compounds. Elements are the smallest form of the matter that has the properties of that matter. They are unique properties. There are about 118 elements. So there are about 118 elements. These are found on your periodic table. Many of them are found in nature. Some of them have been man-made in particle accelerators. But elements cannot be broken down into smaller parts. So an element is that's as small as it gets, in terms of chemically breaking something down. When you get into nuclear chemistry, things get a little weird when the nucleus starts flying apart. But elements are the simplest form of matter that maintain the properties of that substance. Compounds are two or more elements that are chemically combined. When we say chemically combined, we're talking about bonding, and there's two types of bonding in chemistry, ionic and covalent bonding. We'll talk more about that in the next unit. So chemicals that are compounds can be broken down by chemical means. So we can't filter one part of a compound out of another. Filtering is a physical process. But we can react something to separate a compound. Heating a compound is typically not going to separate it. It's going to cause it to change its physical state. Maybe that compound's a solid, and then we heat it, it becomes a liquid, and then we heat it some more, and it becomes a gas. So we cannot separate this by any kind of physical means. We'd have to do something chemical to it, react it with something else to separate it. There are some compounds that, of course, when you heat them enough, they just start to decompose, and that's a little bit different. I said there's 118 elements. The answer to the question is how many compounds are there? I mean, there's just no knowing. This is what we know. There are about 30 million compounds that have been cataloged. So to say we know exactly how many exist, we really don't. But there's 30 million that have been cataloged in scientific inquiry. So I expect there's way more than that, and we just don't know what they are yet. Yet being the key term. Mixtures can be classified. So substances that are pure are elements and compounds. Everything else that we know is a mixture. And there's two types of mixtures. There's heterogeneous mixtures. You may have heard a chemistry teacher or a science teacher call that heterogeneous, so it's the same word. I say heterogeneous. So hetero as a prefix means different, whereas homo as a prefix means the same. So a heterogeneous mixture is one there you can see different phases. So it has more than one phase. If you think about a heterogeneous mixture, maybe, a salad. A salad has the lettuce phase. It has the cucumber phase. It has the tomato phase, the onion phase, whatever it is that you like to put in your salad, a pepper phase. For me, there's a cheese phase because nothing's so good that you can't add cheese to it. So a heterogeneous mixture has more than one phase. You can see the individual pieces of the mixture. So for a heterogeneous mixture, it's really easy to know, hey, that's a mixture. That is not just one substance. That is not a pure substance. For a homogeneous mixture, you may have heard that, homogeneous. A homogeneous mixture you can't see the different phases, and that makes it a little bit more difficult to distinguish the fact that it's a mixture. You might look at a homogeneous mixture and think that it's a compound or an element. But think about milk. If you look at your milk container at home, it says right on it the word homogenized milk. So what they've done, I don't know if you've ever seen milk straight out of a cow, but it does not look like what is in your refrigerator. Milk straight out of a cow is all separated, like you've got the cream part and all those little fat globules and stuff in there. So what they do is they take that milk and they make it so you can't see the little parts, and that's called homogenizing, making it the same. Some people say that our society is trying to become more and more homogeneous, making us all the same instead of having individual traits and ideals that we stand for. But homogeneous means, homogeneous mixture, homo means the same. These are things that look like they're the same thing. It has one phase throughout the entire mixture. So you can't see the different parts of a homogeneous mixture. Think of sweet tea. Like sweet tea is a homogeneous mixture of water, particles from the tea bags, and some sugar. And you really can't separate one out from the other. It seems all like the same thing. Mixtures can be separated by physical means. A heterogeneous mixture, you can sometimes just separate it by picking the little parts of, picking the parts out. You can often separate them by magnets. You can separate it with filtering. A homogeneous mixture is easily separated by distillation. If you've ever heard of a still is something that distills alcohol from people that are making moonshine. It basically evaporates it into a gas, and because things will turn into gas at different temperatures, they can evaporate it and then condense it back into a liquid and catch it and separate it out and make sure those substances are pure by distillation. So when we are representing particles in chemistry, we are going to represent particles by using BBs, I should say, in this chemistry class. And when I say a BB, I'm talking about like a little round metallic sphere, like from a BB gun. So if you draw that, it's just going to be a circle, a sphere. And then if you're really artistic, you might, I don't know, shade it or something. I am not very artistic. So an element is going to be represented by a BB. One little BB, a substance, right? If we wanted a different element, maybe we would draw a BB, and in that BB, there would be a pattern. And we're like, okay, this element 1 is different than element 2. Its BBs are different. Okay? And if we are going to represent a compound, what we're going to do is touch the BBs. So if we want a compound of water, maybe we would say the element hydrogen is this element here, and this BB represents a particle of oxygen. We know that water has the chemical formula H2O. We would have one BB of oxygen, so one oxygen particle, kind of looks like that. And then we would have 2 hydrogen particles that were attached to it. And they would look like that. And that represents a compound of water. The hydrogen and oxygen are chemically combined. So if you wanted another one of those, you would have to draw another whole compound of those particles. So that's how we represent BBs. That's how we represent substances in this class. We're going to use little BBs. BBs should not be dots. We're not going to just dot all over our paper. We're going to be intentional about drawing circles on our paper. Okay, so the next slide has a bunch of elements, compounds, and mixtures that I have drawn using BBs. And let's take a minute to separate them out. So we can have elements, we can have compounds, those are pure substances, or we can have mixtures. We can have mixtures of elements, We can have mixtures of compounds. We can have mixtures of an element and a compound. So if you look at these, I want you to look carefully at these slides, and I want you to identify each little box as either a compound, as a pure substance or a mixture. Really quickly. So pause the video and define them as a pure substance or a mixture. Okay, so as you've looked at those and defined them, I see here 2 pure substances and 3 mixtures. So we can see that pure substance number 1, we have different types of BBs. We have this big BB here attached to 3 smaller BBs. So this is a pure substance, and this pure substance is a compound. My abbreviation for compound is CMPD. Our other pure substance down at the bottom has nothing touching, so this is going to be a pure substance, and it's going to be representing an element. We can see that all of these little BBs look the same. There's nothing different about them. Our first mixture at the top here, we can see that these BBs are not touching each other, so this is going to be a mixture of elements. In this next mixture, we have a mixture where BBs are touching each other, and we can see that there's this type of compound, since we know the BBs are touching each other. There's this, and then there's this. So this is a mixture, and it happens to be a mixture of compounds, 2 different compounds. Again, my abbreviation for compound is CMPD. And on the last depiction here, you can see we have a compound where we have 3 BBs and they're touching. And here we have elements down at the bottom. Now these elements are touching, but that doesn't necessarily mean they're bonded. Remember that compounds have different elements in them. So this might indicate the physical state being a solid state where the BBs are really close to each other. So what we're showing here is solid down kind of at the bottom and another compound at the top. We might say that this is a heterogeneous mixture where that solid has separated to the bottom and the solution is on top. But right now, let's just stick to mixture, and it's a mixture of a compound, that set of 3 BBs that are touching, and an element. So I hope you have a way, an idea of how we're going to visualize elements, compounds, and mixtures, and that you have from this the definitions of element, compound, and mixture. All right, you're done.